I built a full-stack app with two completely independent backends, one in TypeScript, one in Python. Same endpoint, same API contract, same behavior. The front end has no idea which one it's talking to. That sounds like a waste of time, and you can definitely argue it was, but it taught me more about both ecosystems than anything else I've done. Here's what I found. This is OutreachAI, healthcare outreach tool. You pick a patient. Configuration is preloaded, determined by the patient's information, and then it streams personalized messages from Claude or Gemini in real time, depending on the model you choose. Here, I'm just putting in an access code to access the live models for the demo. Pretty standard AI feature. What's weird is behind it. Two backends, Next.js API route in TypeScript, FastAPI service in Python. Same endpoint, same validation, same streaming protocol. I built the TypeScript version first. I already knew Python from smaller projects, but I'd never really built anything production grade in it. Companies I saw wanted Python experience, so instead of pointing at coursework, I rebuilt the backend in FastAPI with full test coverage and Docker. First problem, keeping the contract identical. Both backends need to validate the same request shape, return the same response, reject the same invalid inputs. TypeScript uses Zod, Python uses Pydantic. Zod is functional. You chain methods, .string, .min, etc. And then the cool part, zinfer gives you the TypeScript type for free. The schema is the type. My actual types file is 16 lines of re-exports now. Zod schemas are the single source of truth for the entire TypeScript side. Pydantic does the same thing with class inheritance and Python type hints. Literal types are enums, decorators for custom validators. One neat difference, alias generator to camel on each model automatically handles snake case to camel case everywhere. Parsing, serialization, JSON schema generation. In JavaScript, you don't need that because the ecosystem already uses camel case. But Python, you're constantly bridging two naming conventions and Pydantic makes it painless. Both libraries also generate JSON schema for your models. I use that to tell Claude's structured output API what shape to return. Same models that validate incoming requests also define the LLM's output contract. One schema, 3 jobs. Validation was interesting. Streaming was where I struggled. Both backends stream LLM response token by token over server-sent events. In Next.js, you build a ReadableStream, get the controller, encode each chunk with text encoder, and enqueue SSE events manually. It's verbose. You're managing the stream lifecycle yourself. Open, enqueue, close, and don't forget the finally block. In FastAPI, it's an async generator. You write a function, you yield chunks, you wrap it in event source response. Done. Genuinely half the code. Python's async generators were made for this pattern, and it shows. Here's where it gets interesting though. Error handling midstream works completely differently in each language. In TypeScript, if the LLM errors midstream, you catch it and enqueue the error event. The controller is still right there. In Python, if your generator throws after the first yield, the framework can't catch it for you. You have to handle errors inside the generator and yield an error event yourself. Otherwise, the connection just drops silently. I spent some time debugging that in Python. The TypeScript version already handled it correctly, so I just had to figure out the Python equivalent of the same pattern. Turns out having a working implementation to reference saves you a lot of time from guessing at framework behavior. 231 tests. 137 TypeScript with Vitest, 94 Python with pytest. The dual backend made testing weirdly productive. I wrote the test cases once conceptually, then implemented them in both. Same assertions, different syntax. Reject empty channels, return 422 for invalid provider, stream returns correct SSE content type. If both suites pass, the backends are behaviorally identical. Honestly, I'd recommend this approach even if you never ship both backends. Write your test suite as spec first. This forces you to think about your API contract before you write a line of implementation code. 2 compose files. Default one runs just Next.js. The Python one spins up both services with the front-end proxied to FastAPI. One interesting architectural note, the TypeScript backend lives inside the Next.js process. The Python backend is a separate container. Same API, fundamentally different deployment model. 3 things. 1. Building the same thing in 2 languages strips away the syntax and shows you the actual concept. Validation is validation, streaming is streaming. After this project, I understand both patterns better, not just 2 implementations of them. 2. I already knew Python basics going in. What I didn't know well was the production ecosystem. FastAPI, Pydantic, async generators, how SSE works in a different HTTP framework. That kind of stuff I couldn't easily find in tutorials. How I actually learned was building something real and hitting those edges. 3. I could have easily listed Python on my resume after taking a course or two, but instead, I built a FastAPI backend with tests, CI, and Docker Compose, all open source. Those are very different conversations in an interview. If you're trying to pick up a second language, courses are great for the basics, but for production stuff, the framework patterns, the async edge cases, the deployment differences, you only really learn that by building something real. Pick a project you've already built and rebuild it. You already know the problem, you're just finding a new way to solve it. Project's open source, links below. Thanks for watching.